Okay, so this is the video lesson for 2.1, which is transformations of quadratic functions. It actually is related to section 1.1, but specifically for quadratic functions. And so it might sound a little bit repetitious, but I'm hoping that we'll go into a little bit further depth. So anyways, there are three kinds of translations or transformations that we talked about in chapter 1. The first one is translations. Okay, and that's where you would shift a parabola right or left or up or down on a graph. The second one is reflections. Okay, and the third one is if you shrink it or stretch it, so if it widens or narrows or shrinks. Okay, so I'm going to talk about these three kinds of transformations, particularly with quadratic functions, or f of x is equal to x squared. Okay, and I'm just going to organize just some basic information for us so that it'll be easier for you to reference later on. So like I already mentioned, there's different kinds of translations when it comes to quadratics, okay? You can either shift it right or left, okay? Okay, side to side, or you can, and that would be horizontally, okay, or you can shift them up or down, okay, and that would be a vertical translation. Okay, so let me see if I can reserve this spot. All right, so in these two categories, okay, it appears to, what you have to do when you want to shift a quadratic right or left is you have to consider the function. And so if the original function of f of x is equal to x squared, then to shift it right or left, we would have to move it by a constant directly on x. So in other words, we are looking for f of x minus h, which would be, so basically plugging x minus h into x squared, you get x minus h squared, okay? And this is the factor right here, this constant, is what moves it in a particular direction. Okay, so if it moves, if h in this case is less than 0, okay, then it's going to be moving it left. All right, and likewise, if h is greater than 0, then it's going to move it to the right. All right, and we'll do an example of that. Okay, so when you plug in a negative value into this function right here, like say -4, it'll become x plus 4, and that's moving it 4 units to the left. But if you put in a positive value for h, like 2, it would make it x minus 2, which would move it to the right by 2 units. Okay, so that's a little bit of a detail for how to move it right and left. Now, it's a lot easier to move a quadratic up or down. Basically, you would take your function, f of x, okay, and all you have to do is add a constant on the exterior, and then we'll call that k. So if you want to move it down, that's when k is negative. So if it was -1, x squared minus 1, it would move it down. I'm going to write down, okay? But if k is a positive, like x squared plus 10, it would move it 10 units up. So that's pretty much it for a vertical shift. Now the other kind of transformation that happens for a quadratic function is the reflection, okay? And I'm going to squeeze it over here. Okay, we'll see if it squeezes. If you have a reflection over the, well, there's two kinds of reflections that can happen, okay? You can flip it over the x-axis or you can flip it over the y. Okay, so you can either flip it or reflect it over, flip over x, or you can flip it over the y. And I'll write axis actually to be a little more descriptive. Okay, so you have these two situations here. Okay, if you want to flip it over the x-axis, it's pretty easy. All you have to do is just negate the function. So you would just find negative of f of x, which is negative x squared. So if you have x squared and you put negative in front, it just flips the graph. If you have 2x squared and you have negative 2x squared, it reflects it over the x-axis. Pretty self-explanatory. Okay, now it's a little bit more complicated when you want to flip it over the y-axis because you have to actually input a negative x into your function. Okay, and what I mean by that is you have to find f of negative x. Okay, so in other words, you need to find negative x squared, which we know that if you take a negative value and you square it, it becomes positive. Okay, so this is a simple example because obviously this reflected over the y-axis is going to be the same thing. Okay, but there are other examples where you might have to flip it over the y-axis and the function is not as simple and doesn't turn out to be the same. All right, so the last thing that you can do to transform a quadratic function is you can either stretch or shrink it. Okay, now there's two ways that you can stretch or shrink it, and it's kind of complicated. You can stretch it horizontally, and of course you can do it vertically. Okay, and it kind of looks similar. Horizontal is like if you want to stretch it horizontal, you're making it wider, and then when you want to shrink it horizontally, you're pushing it together, which is sometimes similar as if you took a parabola and you grabbed the vertex of it and you pulled it apart, it would get narrower, but then if you pressed it together, it would also get wider. So the resulting parabola kind of looks the same. You have a parabola that opens up and down, but depending on whether you do it horizontally or vertically, the calculations are different. Okay, so let's go ahead and talk about that. So if you wanted to stretch a horizontal graph, what you have to do is you have to plug in a coefficient in front of the x for f of x. So in other words, you have to find a of x. All right, and when you do that, you plug it in to whatever x you have, which in this case is x squared, and you get a resulting function. All right, when a is when a is a decimal or a fraction, okay, that's between 0 and 1, okay, for example, 1/2, all right, then that actually stretches the graph. So I'm going to write stretch, okay, I'll put a line here. But if a is greater than 1, so it's a whole number, okay, then it's going to shrink the graph. All right, and likewise, sorry, squeezing it over here. To do a vertical stretch or shrink, you would just have to multiply the whole function by a coefficient or a value. So if you have f of x, you just multiply it by a, and it would be ax squared. Okay, you would take your x squared and just multiply it by a coefficient in front, and that vertically stretches or shrinks your graph. Okay, so if your a is greater than 1, then it stretches it, and obviously if a is between 0 and 1, like it's a decimal or a fraction, then it shrinks it. Oops. 0, a, 1, and then that shrinks it. Okay, so I put all of the calculations that you would need for these basic transformations onto this board, and you can use it as we move forward with an example, okay? So let me go ahead and erase this, and hopefully have this in your notes. And then you can see how we can apply this information in the context of an example. Okay. So let's start with an example. Let's say we start out, say we want to find the function g of x.